Hello, in this video I'm going to be graphing a cosecant function involving transformation. So basically the point of this video is I'm going to show how I like to graph the reciprocal of one of the functions, one of the three primary functions, sine, cosine, tangent. So I believe in class the way we graphed the functions that needed to be transformed, we got all the characteristics of the graph. We got all the characteristics of the function, and we got like 4 key points. What I'm going to do is just to mix it up and just to show my true understanding of it, I am going to graph this using transformation. So I'm going to use a transformation table. So I'll read the question and then I'll solve it. So graph one cycle for the function f at x is equal to 2 cosecant 5x. Okay, so basically what I did was I created a table of values for the parent function, which is y equals cosecant x. I plugged in the key points for the x values in radians, because this unit we're working in radians. And then I just entered these points into the calculator. This stands for undefined. So basically there is a vertical asymptote at an undefined point. And now what I'm going to do is I'm going to use transformation. So this is the transformation format I use. I don't think it really matters what letters you use as long as you know what the letter means, but this is the format I use. And I got my characteristics from this function. So a is equal to 2, k is equal to 5, and d is equal to 0, c is equal to 0. So basically, the only thing we're dealing with are vertical, we're dealing with a vertical stretch, and we're dealing with a horizontal compression, right? So now what I'm going to do is I'm going to use this transformation format. So I'm going to put these points into this transformation format to get my new x points and new y points, and then once I do that, I can just plot those points on the new graph, and then I will have graphed one cycle for this function. Okay, so basically what I did was I just used this transformation format, so x over k plus d for the x values and y plus c for the y values. So here, our k value was 5, so we just plug in 5 for k, right? And d, well, it's 0 because there's no phase shift, so I'm not even going to write that. For y values, our a value is 2, so we put in 2 here. C value, there is no c value, there's no vertical shift, so I just don't even include it, okay? So now what I did was, this x value, the parent function, 0 divided by 5 is just 0. Pi over 2 divided by 5 is just pi over 10. Pi divided by 5 is just pi over 5, and so on and so on. Now notice how, since there's no phase shift, that also means the vertical asymptotes, they're going to stay where they are. They're not going to move. The only transformations that are being applied are vertical stretches and horizontal compressions, but we're not actually moving the graph. So the undefined points, they're going to be in the same spot as in the parent function. So 0, it's undefined. Same here, it's undefined. Here, this is pi. It got transformed to pi over 5, but it's still undefined. And same thing for the bottom one, okay? So now that we have our new points, we can plot these points on a graph, and then we will have graphed one cycle for the function. So what I'm going to do is I'm going to erase this and plot the graph here. Okay, so basically what I did was I made a graph. This is 2 and this is -2. At 0 there, it's undefined, so there's a vertical asymptote, so I didn't draw one because of the y-axis. At pi over 5, it's undefined, vertical asymptote, so we have a vertical asymptote here. And same thing for 2 pi over 5, undefined, so vertical asymptote, okay? Now here, at pi over 10, we're at 2, so I plot the point there, and this is what the function looks like. And at 3 pi over 10, it's at -2, so I plot that here, and this is what the function looks like. If you don't know why the function looks like this over here and why it looks like this over here, that's because you need to know what the parent function looks like. So you need to know what f at x equals cosecant of x looks like. You have to know what this function looks like before you graph with transformation. So if you don't know what the parent function looks like, if you don't know what cosecant x looks like, I did make a video on how it looks and why it looks the way it does, so go watch that video if you don't know why the function looks like this. But yeah, this is what the function looks like. So I have graph one cycle for this function, so if you plug this equation into Desmos, you will get the same thing.